Hi, this is Timon with the Open Networking Foundation, and today we're announcing two projects that are really synergistic and work with each other. The first is called SDCore, which is a platform, a mobile core platform for connectivity as a service. And the second is SDFabric, which is a full stack programmable networking fabric that exposes P4 programmability. And the two work together in some really exciting ways that I'm going to share. So, SDCore is a full 4G plus 5G solution supporting LTE, 5G standalone, and 5G non-standalone. But it's optimized for cloud deployments and for edge cloud, and it's ideal for building solutions for private 5G for enterprise. SDFabric is a full programmable stack optimized for edge cloud, designed to be developer-friendly, cloud-managed, and exposing software as a service APIs to make it an integral part of building enterprise digital transformation projects. It also has a P4 implemented UPF function, and this is where the two projects really come together. That SDCore, running on top of SDFabric, is able to implement a UPF and push it down into SDFabric to be able to run that functionality in hardware with really fantastic performance numbers. So, exciting to have these two coming out and backed by the whole ONF community of both operators and this emerging space in the private enterprise and private 5G space. So the background here is that we're moving from this hyper cloud environment to this highly distributed set of clouds, and I think that we're all sort of familiar with that now, with both edge clouds in the enterprise and telco edge clouds, and the capabilities that we need to support now are the ability to deploy applications that are multi-cloud aware and can run components in the various clouds where the components are best suited, out at the edge or in the centralized cloud, where we can support IoT and a mass proliferation and explosion of endpoints and devices, where we can support 5G and connected devices. So we have these clouds, but it's devices are now onboarding into the clouds using 5G, and we have to find ways to seamlessly connect this explosion of 5G devices at the edge of the network. And at the same time, AI and ML is getting applied across the board. There's a desire in this whole Industry 4.0 movement to attach these devices over 5G and be able to leverage cloud resources to operationalize things using the best of machine learning capabilities and deep learning. So, SDCore is at its foundation a 5G plus 4G mobile core. And we've built up from two open source projects. OMEC and Free5GC provide some of the foundational elements. But we've added quite a lot on top of that. It's designed to run dual mode out of the box. So simultaneously supports a mix of 4G and 5G, which is great for migration and simultaneously supporting all kinds of end user devices. It's edge cloud optimized. So it comes with three different UPF functions. So this is quite novel approach that we believe and recognize that there are going to be different classes of device and application, and especially in this Industry 4.0 movement, the amount of bandwidth, the latency requirements are just going to go through the roof. And so in response, we've come up with three different UPFs. One that's P4 based, I mentioned that, so that's a very, very high throughput, very low latency, very deterministic, but supports a smaller number of end devices at any single point in time. And then there is a DPDK, Intel optimized UPF that runs, on an Intel server in a very performant way and can support quite a proliferation of devices. And then there's a very called the Flex UPF, but it can run on any device or any cloud. It's not hardware dependent in any way, and it can scale up and can scale out in a cloud native way to support an unlimited number of end users and devices. And one can mix and match these UPFs simultaneously, and one can run UPFs in multiple edges, all being managed and run out of one common core that's running in the public cloud. All of this is designed to be cloud native. It leverages the best of CI/CD and DevOps, automated testing, continuous deployment of new features and functions, and all that. And it's all designed to be SaaS ready, to deploy software as a service style. That's with APIs for building cloud managed applications and deploying connectivity as a service. So SDCore is, on the inside, it supports all the standard 3GPP interfaces. And so it's possible to use components, 4G, 5G components, mix and match UPFs, mix and match, any of the elements of 5G core. And so, so 5G core comes all packaged together. And as you'll hear, it also comes packaged with Ether, which is a complete private 5G solution. But one can also consume components of it or mix and match and integrate with other core components if one so chooses. So that's SDCore, a cloud-native solution for deploying connectivity as a service, both as a holistic solution or as components that can be integrated in with other core components to assemble custom solutions as one wishes. And the second big piece of this announcement is SDFabric. So SDFabric is this full stack SDN networking solution. It's deeply programmable, and as an example, the UPF function I was just describing from SDCore is implemented on top of SDFabric and would not be possible without SDFabric. And that's the reason we're announcing the two at the same time, because they really are intertwined to a certain extent. SDFabric is designed to be deployed and run from the public cloud, supporting multiple edge clouds. And the theme might sound familiar to the SDCore pieces. I mean, this is where we believe the network is going, and deployments are headed towards this edge cloud structure, and SDFabric is optimized for such a structure. It's a cloud-native implementation, again, all based on CI/CD and DevOps and continuous deployment, all the way to pushing Kubernetes all the way down into the switch. And the design here is to minimize what runs on physical switches. So at each edge, there's a spine leaf fabric. It can be as small as 2 switches, or it can grow up to a number of racks of switches and servers. And but we minimize what runs on each switch. We run the thin switch stratum OS, and then all the intelligence and control moves into the cloud. Running at the edge cloud, we have ONOS and a set of applications that pull that fabric together into a cohesive solution. And then this is all then controlled and orchestrated from the centralized public cloud. And all of this is really designed and optimized for application developers, moving to a realm where it used to be that as an application developer, you just trusted the network with a black box. You sent a packet out and you hope it came out the other side. Now we're opening up the network so developers have both visibility and control of the network and can actually start to push functionality into the network and can start to really understand exactly what the network is doing and alter the behavior of the network to suit the application better. So, SDCore and SDFabric, they work together in the ways I described. They are both also integral parts of the more, the holistic Ether solution, which is the private 5G connectivity as a service solution. So SDCore and SDFabric with SD-RAN, those three together really holistically then provide all the components necessary, and then Ether then wraps that together into a solution for delivering private connectivity and private cellular services to the enterprise as a SaaS offering. So, we're announcing SDCore and SDFabric today, but both of these projects are in early production deployments already as part of Ether in a worldwide network with over 15 live sites as of today. They're combined, with SD-RAN to make this, cohesive 4G, 5G solution that's deployed. Today it's deployed with 4G radios, and soon you're going to hear about announcements of 5G radios being supported and deployed as well. So that's what we have for you today. And if you have any questions, please, come visit the ONF website and reach out to me if I can be of help. Thanks.